All right, so SAT, ACT prep part 2. So if Larry has X amount of apples and they were split among a class of 12 people, how many apples did each person get? So whenever you want to find out the price per one, you take the total amount and divide it by the total number. Okay, so here our total amount of apples is X, and we're going to divide it by the total number of people, 12. Right? Okay, Jenna has to get through her emails, so she has set aside M minutes to do it. This task is modeled by the equation E equals that, where E is emails. What is the meaning of the 1250? Okay, so this goes back to Y equals mx plus b, right? Where m is the slope, but we also call this the rate of change. Okay, and then b was your y-intercept, but in story problems, we're going to refer to this as like the start value or like a fee, like a one-time fee or something. So right now the 1250 is our y-intercept. All right, so it's technically our start value right now, right? So she started with 1,250 emails. So if what is following equivalent to x over 5? All right, so first we need to solve for x, okay? In order to do that, we'll add 5y to both sides. So we get x equals 5y plus 75. And then to get it over 5, we're just going to divide everything by 5. All right, so we get x over 5 equals y plus 15. All right, so when a is divided by 3, so we'll do a divided by 3, the remainder is b. So after we subtract here, the remainder is b. Now, what we know about division is that this here is going to be a multiple of 3, right? And then when we subtract a minus the multiple, we get b. So let's kind of work backwards and think through this. So a minus the multiple will give you b, right? So a minus a multiple, so let's just use a number, equals b, right? So if they're actually wanting us to find a, let's solve for a. So we add that multiple to both sides. A equals b plus the multiple. Okay, so which of those looks like this? Well, b minus no, 3 minus no, no, plus b and a multiple. There you go. Okay, in triangle ABC, 3a equals b. So which of the following is equivalent to c? So I didn't give you choices because I just want you to find out what is equivalent to c. So we know in a triangle, so we have a, b, c. We know total is 180 degrees. Okay, so we know that 180 equals a plus b plus c. And we know that 3a equals b. So we'll substitute that in. Okay, so we get 180 equals 4a plus c, and they want to know what's equivalent to c. So we'll subtract the 4a over to make it equal to c. There's our answer. So for this one, when I was editing, I did not like the way that I explained this. So this is actually on a different day, and I'm sorry, but my neighbor is mowing his yard. So if you hear that in the background, I do apologize. But I really did not like the way I explained it, and I want you guys to really understand this question. So here we go. So density of trees in a certain forest from 2011 to 2018 can be modeled by this linear equation. We know it's linear because the power on the y is a 1, where y is the number of years since 2011. Which of the following can best describe the meaning of the number 13.2? So remember from the previous problem, y equals mx plus b, right? This was the y-intercept, and this is the slope, but the slope is also called the rate of change, okay? So y-intercept or start value. Okay, so let's look at our options. So we know that 13.2 is the actual rate of change. So it's the change in the density from year to year. So does that represent the total number of trees? No. The estimated difference between the tree density in 2011 and 2018? No, because this is a rate, not the actual difference, okay? Because that would be the number, the difference between the number of trees in 2011 and 2018. So no. The estimated increase in the tree density each year, yes, okay, because that is the rate of increase per year. Then the tree density, no. All right, the volume of a rectangular solid is 15A. So we have to remember the formula for volume is length times width times height. And we know that that equals 15A. If the dimensions of the solid are the integers a, b, and c, so a times b times c, what is the greatest possible value of c? So remember, integers are whole numbers and no fractions. Okay, so the first thing we notice is that a is on both sides, so let's divide both sides by a and get rid of it. So we get 15 equals b times c, and since it wants us to find the greatest possible value of c, let's divide both sides by b and solve for c. All right, so 15 divided by b gives us c. Okay, so, and since they have to be integers, so whole numbers, we can't divide 15 by anything to get 25. So there you go. But 15 can be divisible by 1 to give us 15, so that is our answer. Okay, so if x equals that and y times x equals that, what is the value of y? So here we're going to substitute in this equation for our x. So we get y times 63 over 4z minus 1 equals 7 over 4z minus 1. Okay, in order to solve for y, we're going to have to divide by the fraction. And if we divide by the fraction, we actually multiply by the reciprocal, also called the flip. So times 4z over minus 1 over 63. Okay, that cancels out. Those cancel out. So we're left with y equals 7 over 63, and then that can reduce to 1 over 9. Okay, so for this one, when a is divided by 7, so a divided by 7, the remainder is 4. When b is divided by 3, the remainder is 2. And a is between 0 and 24. B is between 2 and 8. Okay. Which of the following could have a remainder of 0 when divided by 8? This means that after you do this operation, the result needs to be divisible by 8. Or in other words, a multiple of 8. So first we need to actually get our multiples, right? So since this is being divisible by 7, or divided by 7, we need to get multiples of 7 first. So we get 7, 14, and 21, because that's between 0 and 24. And then over here we need to get multiples of 3. So 3 and 6 and 9 cannot be in there. Now, since our remainder is 4, that means after we subtract something from A, the remainder is 4. So what we're going to have to do is add 4 to these numbers to see what our original A would have been. So 7, 8, 9, 10, 11. 14 plus 4 is 18. 21 plus 4, 25. 3 plus 2, 5. 6 plus 2, 8. Now we check to see which ones are outside of the range that they gave us. Okay, so 25 is outside of 24, so no. And here, if you'll notice, there isn't an equal to. It's only less than. So this 8 will not work either. All right, so let's start looking at our options. So A divided by B, well, 11 divided by 5 does not give us something that's divisible by 8. 18 divided by 5 doesn't either. All right, B divided by A. Oh, that doesn't either. What about A plus B? So 11 plus 5 is 16, and that's definitely divisible by 8. What about 18 plus 15, 18, 19, 20, 22, 23. That doesn't, but at least the 16 does, all right? What about A times B? Well, 11 times 5 is 55. That doesn't work. 18 times 5, that's not going to give us something divisible by 8 either. All right, so our numbers are 11 and 5. When you add them together, give you 16, and that's divisible by 8. Okay, so if 2x, 2 divided by x, and 10 divided by x are integers, which of the following must also be an integer? Okay, so recall an integer is a whole number that's either positive or negative. Okay, so no fractions, whole number that's positive or negative. So the first thing that comes to mind is, what number is both 2 and 10 divisible by? That will give you an integer, right? So that's obviously going to be 2, because if we go any higher than 2, we're going to get a fraction here. So 2 times 2, 4, 2 divided by 2, 1, and then 10 divided by 2, 5. Okay, so that all works. All right, what else can we divide by that'll still give us an integer? But we can also multiply here, that'll still give us an integer. Well, if we recall from the other problem, when we divide by a fraction, we multiply by the reciprocal. So what fraction can we multiply here that'll give us 1? All right, so let's say x equals 1/2. Over here it was x equals 2. All right, 2 times 1/2 will give us 1. 2 divided by 1/2, right? So that's 2 times 2 over 1 gives us 4. And then 10 divided by 1/2, that's 10 times 2 over 1 gives us 20. All right, so now we have two variables that will each give us integers in all of this. So now let's look at our options. So x divided by 2. Well, if we do that by these x's, will it still give us an integer? So 2 divided by 2, yes. 1/2 divided by 2, 1/2 times 1/2, and that's 1/4, so no. Okay, option 2 is just x. Well, that's 2, but here it's 1/2, so no. So option 3, 8 times x. So 8 times 2 is 16. 8 times 1/2 gives us 4. All right, so it's just, those are both integers, so it's just D, 3 only.